presentation on our Project 4, which is a space settlement at the Callisto-Jupiter-Lagrange points L1 and L2. My name is Emma Mahoney, and here with me I have Dominic, Kasparavicius, Alia Maguire, Ben Zarza, and in Dublin, Niamh Pearson and Nia New. The word "for" means harvest in Irish. In Irish cultural tradition, for it goes beyond agriculture meaning. It signifies preparation, careful stewardship of resources, and survival through the darker months. Our space settlement reflects these same ideas. It involves harvesting of materials from space, including helium-3 from the Jovian system and metals from nearby bodies. Sustaining a closed ecological system, carefully managing to secure long-time survival. Now I pass you on to Dominic.
The Jovian system consists of Jupiter and its 100+ moons. Callisto is an ideal location for a settlement due to its low radiation levels and its ideal location in the Jovian system, along with its resources available on and beneath the surface. Jupiter's moons and magnetic fields. Callisto orbits outside Jupiter's most intense radiation belts. It experiences daily radiation levels orders of magnitude lower than Europa, Io, and Ganymede. The radiation levels at Callisto are comparable to deep space background values, making it the safest location in the Jovian system for human activities. I now pass you back to Emma.
Callisto is considered the best candidate for a space settlement as it has low surface gravity. The idea is to anchor tether to Callisto's surface and extend it to the point where the gravitational pull between Jupiter and Callisto balances. To remain the tension, to extend the cable to its counterweight, which makes it over 100,000 kilometers. The challenge is the material has to be strong but also lightweight, and it has to be able to withstand radiation over long periods of time. The space elevator would be could transport materials far more efficiently than rockets ever could. Jupiter's Trojan asteroids were formed over 4 billion years ago when the solar system was first formed. Most Trojans are dark objects containing rocky, icy, carbon-rich material. Studies suggest that they contain silicates, carbonous compounds, organic materials, and water-bearing minerals. These would be used for life support systems and water extraction. The Hilda asteroids occupy a 3 to 2 orbital resonance with Jupiter. They are relatively stable orbits, and carbon-rich composition make them practical resource excavation material. There are many different ways to mine asteroids: surface excavation, thermal radiation, orbital relocation, and the Mond process. The different types of asteroids are the C-type asteroids, which would be used for carbon processes. The S-type asteroids would be used for industrial applications, and the N-type asteroids, which are the most rare, would be used for structural and industrial applications. Now I hand you on to Anya.
Callisto is made of approximately 55% water ice, which can be melted and broken down into hydrogen and oxygen. According to a study by Troutman et al. In 2003 on in situ resource utilization, this is essential for rocket propellant, which is composed of liquid hydrogen and oxygen, as well as life support systems such as drinking, food growth, and breathing. Callisto can also act as an emergency shelter in the case of any issues with our settlement 4. We calculated Callisto's Lagrange points L1 and L2 and found that its orbit is ideal for our settlement. 4 will be located on L2, which is 50,000 kilometers from the center of Callisto, and a dedicated logistics and industrial space station will be located on L1, which is also 50,000 kilometers from the center of Callisto. Callisto orbits Jupiter in 16.7 days, and its same side will always face Jupiter, the same way that the moon's same side always faces the Earth. Up next is Ben.
The nuclear fusion reactor will be built on the surface of Callisto for mining and extraction of helium-3. Now, what is nuclear fusion? Nuclear fusion is what powers the sun and the stars. It is a process where 2 smaller nuclei are combined to make one large nucleus. According to Einstein's E equals mc squared, small mass is converted into electrical energy. Because c squared, the speed of light squared, is so tiny, only a small mass can be used to combine large amounts of energy. It is important to note that humans have not yet harnessed the power of nuclear fusion, but we are assuming for our project that they have. Now, why choose helium-3? Helium-3 is very rare on Earth, but it can be found in large quantities in the atmosphere of Jupiter. According to the long-term space resource studies, helium-3 could be extremely valuable for future space energy-based economies. In relation to fusion, helium-3 produces fewer damaging neutrons, which may allow for major advantages for our space settlement. Now, the helium-3 principle for fusion. We are considering a deuterium-tritium chemical reaction for 4. It involves 2 isotopes of hydrogen and can release 18.4 mega electrovolts of energy. Unlike most other common reactions, this provides naturally charged proton particles instead of high energy neutrons, which results in fewer radiation damage to our reactor particles. Now I'll hand you back to Alia.
Thank you for listening, and thank you to our teachers, Mr. Keneally, Ms. Considine, Mr. Horgan, and Ms. O'Gorman for their help. And a special thank you to our sponsors for making this trip possible. Thank you.